In this video, I will introduce the teaching ratings data. We have been working with the teaching ratings data from University of Texas, and the underlying question is, if students' teaching evaluations are influenced by the looks of individual instructors, or you can ask if their teaching evaluations differ by gender, or if good-looking instructors get higher teaching evaluations. I obtained this data from Professor Daniel Hammermish, who has written a paper about how beauty may impact an instructor's teaching evaluation. In fact, he has written an amazing book called Beauty Pays, in which he answers these questions, such as do you think good-looking employees get higher pay or faster promotions? Do you think good-looking instructors get higher teaching evaluations? And the data comes from University of Texas. It's a survey data obtained from 463 courses. So the data is first referenced in the book Getting Started with Data Science, Making Sense of Data with Analytics in Chapter 4. There are variables that essentially define the attributes of instructors and characteristics of the courses. Some variables are continuous, others are dichotomous or categorical variables. So the primary two variables of our interest are beauty score, which is basically the physical appearance of an instructor, which was ranked by a panel of 6 students. And I think that they have normalized the beauty score such that it had a mean of 0 and variance of 1, or a standard deviation of 1. It's the same as Z transformation. The dependent variable, the variable of interest, is evaluation, which is basically the teaching evaluation ranging between a scale of 1 to 5, 1 being very unsatisfactory, and if the student found the course to be excellent, then it's 5. And then there are other dichotomous or binary or categorical variables such as minority, if the instructor was a non-Caucasian. Age is a continuous variable, and it's the professor's age or instructor's age. Gender being male or female. Native stands for native English speaker, if the instructor was a native speaker of English language, 1, 0 otherwise. If the professor was tenured, 1, 0 otherwise. I have produced some descriptive statistics for your reference. For instance, for the continuous variables such as age and beauty and teaching evaluation and the number of students who were enrolled in the course on the number of students who performed the teaching evaluations, I produced the descriptive statistics such as the minimum, the maximum, mean, and standard deviation. For categorical variables such as gender, female, yes or no, visible minority, yes or no, person being a tenured professor or otherwise, I produced the frequency distributions and percentage of individuals falling in one category or otherwise. Notice that the teaching evaluation score is 3.99 with a standard deviation of 0.55. And let's see if I were to produce a histogram of this variable teaching evaluation, how will it look like with raw data? And if I were to use the normal distribution and feed the two parameters, that is the mean and the standard deviation, how will the same distribution look like using a normal distribution? I am presenting here the distribution of the raw data on left side and the presentation of the same data with the same parameters, the mean and standard deviation, using normal distribution. You could see that the data are not exactly following a bell curve. This is the raw data, and it seldom does. But then the theoretical distribution looks like this. Essentially, the same data set with a mean of 3.998 and standard deviation is presented here, and then a normal distribution drawn from these two parameters appears here. So it's much smoother. Theoretical distributions are much smoother than the raw data.